Here is the BJT circuit symbol for both NPN and PNP. Notice the direction of the arrow that denotes the current flow and the placement of the emitter and collector terminals. Now let's study the current voltage characteristics of the NPN. Consider this conceptual circuit. We are going to draw a graph of IC versus VCB for various values of IE. To do that, we first fix IE to some value starting from 0. Then we are going to change the value of VCB. We will then measure IC for every VCB. We will then change the value of IE and repeat the whole procedure. Notice that in this configuration, the base is forced to be at 0 voltage and it is the common terminal between the output at the collector terminal and the input at the emitter terminal. We are going to get a graph like this. Now the collector current and the emitter current are related by this equation IC equals alpha IE. This is true for every value of IE. Now IC also depends on the collector voltage. This is due to an effect called the early effect. Because of this, the equation for the collector current IC has to be modified slightly. We are not going to be studying that in this module, but we have studied this in quite detail in the previous module about the MOSFET. So a link is provided in the instructor's notes through which you can go back and take a look at the early effect. Now let's look at another configuration. This is the common emitter configuration. In this we plot IC versus VCE for fixed values of IB. So the first step is to fix IB. The next step is to vary VCE. The third step is to measure IC for every VCE. And the fourth one is to repeat the procedure for a new value of IB. Now let's look at the graph. Here we are, IC versus VCE. You can clearly see the two modes, saturation and active. This is, however, an expanded graph and not the full graph. Why? Because near the IC axis, the graphs are bunched together. We, however, have to make one important observation here. Notice this point on the graph IB equals IB2. Its coordinates are given by VCE sat and IC sat. This is not the point at the boundary between saturation and active. It is just a point that we have chosen in the saturation region. Now before we move further ahead, let me make one observation. The gain beta is different for each mode. Therefore, we add a subscript to it to denote the mode that we are working in. The equations relating beta and alpha, however, remain the same. For the forward active region, we are going to have beta F. Now, look at this point here. This is the value of the collector current at the boundary between the saturation and the active region. Its value is given by beta F multiplied by IB. Also note that IC sat is less than beta F IB. Now, since we have chosen the value of IC sat, clearly the transistor in saturation is operating at a beta different than beta F. Agree? We call this beta forced, and it is equal to IC sat over IB. Clearly, beta forced is less than beta F. The ratio of beta F to beta forced is known as the overdrive factor. The greater the overdrive factor, the deeper the transistor is driven into saturation and the lower VCE sat becomes. This is because a greater overdrive factor denotes a lesser beta forced, and since beta forced and IC sat are directly related, that implies that IC sat is at a lower value and so VCE sat is also lower. Get it? Now let me quickly write down the conditions for the transistor to be in the active mode and the saturation mode. Specifically, we are going to be writing certain numerical values that will force the transistor to be in either of those regions. Now, in the active mode for the NPN, for the emitter base junction to be forward biased, we have VBE greater than a quantity VBE on. VBE on is approximately 0.5 volts and a typical value for VBE is 0.7 volts. For the collector base junction to be reverse biased, VBC is less than or equal to a quantity VBC on. VBC on is approximately equal to 0.4 volts and VCE is greater than or equal to 0.3 volts. This is the condition for collector base junction. Moving on to the saturation mode. The emitter base junction is to be forward biased and we have the same condition, VBE is greater than or equal to VBE on. Now the collector base junction is also going to be forward biased in the saturation mode. And so we have VBC is greater than or equal to VBC on, VCE is between 0.1 and 0.2 volts, and VBC is between 0.5 and 0.6 volts with VBC on again approximately equal to 0.4 volts.